Yes, sir. Yes, sir.
It's good. All good. Fine.
Yes, sir. Yes, sir.
Just let me set my screen. Just okay. Could you please let me know at what time I could be able to connect the PDF file? Is it, can I start at 9 or 10 o'clock? Because too late night here. So if you don't mind,
Professor Chakravarti,
yes, yeah.
welcome. Welcome.
Thank you so much.
In another 1 minute, we are going to start.
Thank you so much.
Sir, shall we start now?
Oh, yes, sir.
Yes,
Yes,
I'm
sir.
ready. Yeah.
Yes, sir. Yes, sir.
A very good morning to one and all. We welcome on behalf of New Rains. We welcome our invited speaker for the second day of RASTEMS 2024, Dr. Chakravarti Ramanathan from Canada, and Professor Vadlamudi, all the delegates and the session chairs. I welcome you all on behalf of New Rains. The today's session starts with the invited talk by Dr. Chakravarti Ramanathan. Let me introduce shortly our invited speaker of the day, Dr. Chakravarti Ramanathan. Is presently working as professor in computer science department at Vanier College, Montreal, Canada. He got his PhD in the year 2009 from University of Rennes for designing and developing a dependable residential gateway to address the failure caused in software, hardware, and network and content provider. He got his postdoctoral fellowship from LAS CNRS, French National Research Center, France, where his research work has elucidated by developing a mission-aware middleware capable of dispensing a dynamic infrastructure for uninterrupted communication between the artificial intelligence systems that are deployed in case of crisis management system. He has been certified as specialist in server visualization with Windows Server Hyper-V and System Center by Microsoft Corporation. He has more than 35 papers in international journals and conference proceedings to his credit. He has been associated as a member of program committee, technical committee, chair, and review board for different international conferences, and he is in active research. Uh, and he has been doing a lot of work for journals, and he is contributing to academics. Now in artificial intelligence, machine learning, cyber physical systems, and autonomous computing. With this short introduction, I welcome Professor Sakravarti Ramanathan to deliver his talk. Welcome, sir.
Thank you so much for the brief introduction. One thing before getting started, how long the talk should I give? Is it 45 or for 1 hour?
45 minutes.
Okay, fine. Like you can have some time for the question session, but could you please let me know if you can be able to look at my cam? Right, it's good. And sorry for that. It's too late right now. It's like more than 11:30 p.m. and it's too dark outside, so I have to
Okay.
come downstairs to keep myself light up a bit.
Okay. Can you share your PPT now?
Yes, I'm going to do it right now. And
Okay.
okay, so could you can you able to look at the screen?
Yes, sir. Yes, sir.
Is it good? Is it clear?
Yes, sir. Yes,
Yeah,
sir.
yeah.
It's showing.
Thank you so much.
Visible,
So
visible.
thank you so much. And just let me know if you really want me to look at my camera. Otherwise, I can turn it off. It's up to you. Okay. So anyway, I will get started right now. Before I give my talk, I would like to extend my gratitude and heartfelt thanks to all the conveners, technical committee members, for giving me this great opportunity to discuss and deliver my research work that I've been doing for some months with some of the collaborators back in India. And like a dream for every researcher, we always do something on the paperwork, believing that will exist in real time or making it real time scenario, right? So in this case, people are talking about smart city environment these days. Everybody talking about the digital twin, AI, machine learning, and remind me, whatever we do in the paperwork is very prelim and very trivial. So the application of all this technology, it takes years in real life implementation, right? That's very thing important to remember as a researcher. Then the second thing, what we have to focus more on that, the technology we try to implement, we always focus to get it done in real time without taking one single criteria, which is called resilience. I don't know how many of you people know the word resilience. For example, if you buy a laptop, you can talk about the robustness of the laptop. What does it mean? So you can say that if I make it crash the laptop into the wall, how much endurance it can able to provide resilience. Okay, one thing. In case of software, how much efficient, how much secure it can able to handle the threat. These are some of the terms we will focus on particular technology. So keep in mind, whatever you do in your real time, you have to keep it the resilience. It has the four main features: make it available all the time, make it reliable, make it secure, and make it safety. Whatever design, that's the first thing as a researcher we have to keep in mind. So keeping in all this the concept, so what I'm going to do, I will give you a small discussion. We'll discuss about this idea, how to build a dynamic smart city environment. Why I say dynamic? Because it's constantly changing, evolving in unpredictable situations, right? So we have to take a lot of data through devices, multiple devices, IoT, you name it, whatever the devices we have. All these advanced devices monitor, provides data to you. Then we have to supervise, make this data to learn by itself. There are many kinds of machine learning algorithms, you know very well.
Sir, your
The-
slide is not moving.
okay, I'm not moving yet. I'm just still in
Okay.
the
Okay,
slide.
fine. Okay,
I
fine.
will do that right now. I'll use the digital twin technology to feed the data so that I can able to simulate the unpredictable situations in the smart city. And that's the idea of this discussion right now. So let's talk about the introduction. I will give you all the technology, prior information to you guys. then the real challenges we face it, then the problem statement. Like these are the main agenda. You will give a talk, right? Then what are the different solutions we can able to adapt it? And FYI, note it down. So this is not the solution. This is the one of the solution. You can able to focus on solving the problem. And I'm going to talk about this different algorithm. Excuse me. Then finally, I conclude with my real-time implementation. And smart city, as you name, the definition is not so important, but we will use the technology and a lot of data-driven solutions to improve the general quality of life. That's the thing. We have living in smart city, but it is not smart enough to improve the quality of life. For example, the traffic, the health, the sustainability, the waste management, you name it, right? So we are going to collect cameras, data through sensors, cameras, IoT, in order to improve the transportation, air quality, utilities, waste, so on and so forth. Now, the data, we are going to take it, but now we will deploy some intelligent agents, some systems. Why? The data can able to be processed. We are going to make some decision making to improve some light, no? Something we can able to apply insightful data from the received data sets right now. So example could be smart traffic lights, which is very adaptable. For example, I don't know how to implement in India right now. If you come to Canada, the timing of the smart light is not changing, and it depends upon the number of people waiting in a particular signal. Is totally adaptive. Imagine right now it's minus 17 outside. We have a lot of snow. Even the car applies the brake, the car doesn't stand at the single time. So they will extend the time. Understand that it's by automatic. It's not by one manual thing. So in the extreme inter, it will give some extra time for the pedestrians to cross the street light. So these are some kind of smart decisions. Thanks to the data we are receiving from the particular signal. And we have to think about the citizen-centric approach. Like I'm explaining, that public transportation is very important these days, waste management and energy distribution. All these small criteria should be optimized, reliable, and sustainable. So if we include all this concept, then we are going to think about we are building a smart city. And now, yeah, we can easily think about building a smart city, but what are the real challenges? When we talk about the data is not single user, the data is humongous. That means thousands of bytes of data coming you real time with a lot of noises, right? So due to different type of noise, and we can be able to find some discrepancies between the training data and the real world data. We learn machine learning, we are going to give some data, often is noise free. In real time, it is not. Remember that, right? So, and the model drift, whatever we build the model in the simulation does not necessarily fit in the real time. So maybe the models might lose its accuracy. That could be possible. So for example, air quality models might be changed due to seasonal changes, new industrial activities. And also we have to take it into consideration about this environmental noise. For example, rain, wind, dust. This will change the entire way we think about the data. And the people, the stakeholders who design the model, if they are not expert, that may lead to a big inefficiency problem. So these are the main challenges when we're thinking about building a smart city. Okay. Now, digital twin. These recent days, people talking about the digital twin. One of my friend, he has his own company who's making this digital twin technology. Is the company name is Sensi now. I'm going to share some of this work, and the credit to is I'm so thankful to him. He allowed me to use some of the slides to work it so that you will get an idea exactly how the smart city in real world might look like that. So a digital twin is a kind of virtual replica of any system or process or entity. So it's not only a building, it's not one, you can't able to think about the city, it could be a small entity. Okay. So the thing is that we are going to feed the real-time data to the system to reflect the current state of the real physical counterpart. That's the thing. Now, the main features, as explained, that since the cities are connected with a lot of sensors, IoT, and data streams, we are going to feed this real-time information to the digital twin so that we can be able to look at the real changes happening at that instant, which is called at that state. And guys, one more thing. If you have some doubt or if you don't understand a concept, you can simply interrupt me and you can able to raise a question. The second thing, simulation and prediction as well. So since we cannot simply change the real physical world, we can able to simulate any kind of scenarios to predict the future behaviors. It's very important as well. And we can able to optimize, as explained, that the stakeholders, they play a major role. They can able to optimize the performance. Okay? So for example, reducing energy consumption in a smart grid. I'm telling the real-time example. I live in a country, in winter, it comes up to minus 45 in the month of February. Minus 45, imagine. So everybody will warm up the heater inside the home, right? So if we have a basement, if someone has a 3 floors, they need more power. That will have a big problem in the grid. So what they will do, they will send us some kind of probe to all the people. Imagine that I'm going for vacation, right, to India in the summer, in the month of winter. Then I will get the probe to, since I'm not at home, they want me to automatically slow down my heat consumption. It's very, very important. Optimization is very, very important. So these things help me to understand the stakeholders to solve the problem. Yeah. And now, as explained that, since I know how to use digital twins, I can able to interpolate the idea of the twins to the smart cities. What I can do, I can able to use for the urban planning. For example, if you really want to build a new roads, or if you really want to apply a new buildings, imagine that I can able to build how a new metro will affect my traffic patterns. Now Chennai, there's a new metro, right? So it will really affect all the traffic patterns. If you really apply this technology and simulate to reroute, to minimize the traffic, you can able to apply the digital twin as well, and transportation as well. So where and at what time and which junction you have a lot of traffic because of some certain criteria, because of some functions, some celebrations, you can able to think about to minimize the delays and optimize the bus routes as well. And I am telling the real-time scenario. The last 3 months before, you have a car race in Chennai. It was a big messed up, right? So in this case, you can be able to mimic what will happen, how to reroute, how to minimize the traffic jam. That's use of real digital twin as well. And energy management, the balance in summer in India use a lot of AC air condition. So how we can able to optimize the consumption throughout the entire city, so on and so forth. So digital twins provide a testing ground for smart cities innovations. So we can able to apply the simulation and predict all kind of different real world systems without any disruptions. Now look at these things. So these are things I taken from one of the friend, the real product. So a virtual 3D, you can able to deploy for each buildings. You can able to look at alarms, consumption, temperature as well, and you can able to color. You can able to put different zones for parking lot, gallery, shopping center, so on and so forth. And when you compartmentalized all the different scenarios, you can look which one takes more power, which is more susceptible. In case of flood, remember India, for example, in summer, everybody is flooded. So we can able to put that, okay, I have prone to flood area. In this case, what could be the optimal way to save the people? So you can put more probes. And you have to supervise. That's very, very important. There's a tool you can able to dynamic map of the building to navigate between different floors and access the equipment as well. If some of the devices are damaged, by a central monitoring system, you can be able to shut down and you can be able to manipulate, control the devices thanks to this particular technology, and you can be able to supervise, control, automate in just few clicks. It's happening right now, guys. It's happening. And also, you are going to watch the real time state of the building. Is vulnerable, is it dangerous, how many people are inside, or you can able to consume a lot of data from the particular device as well. And moreover, there is a way to interact equipment itself. So how many kind of sensors are inside a particular floor? For example, I can able to put very important information about a patient in the hospital, so you can able to monitor the particular patient in case of disaster management recovery systems, right? And also direct and intuitive interaction at the finest level. You can able to analyze and compare multiple data. That's also very, very important. Then you can able to follow the status of each equipment. In case of malfunction, that will be alarmed. So these are the things you can able to view at the global level. And finally, and time scheduling automation as well. So since you have a lot of probes on the devices, you are going to create annual time schedules to more or multiple buildings. If there is new building, the probe could take long time to reschedule. In case of old building, all the devices should be automatically updated, automatically reset or reset factory. So you can be able to allot some of this calendar as well, scheduling. So you can be able to manage national, regional, local calendars, ability to probes on the sensors as well. Yeah. And finally, as explained that this is a one more application for the energy efficiency. We can be able to track the energy consumption, analyze and compare consumption over a period of time, at which area, which region, which zonal, that might influence a lot of energy consumption. What kind of devices takes more consumption? What's the reason? Why? Can we be able to susceptible of that? So these are things we can be able to track in global level. In case of equipment deviations, we are going to get some messages directly back to the sensor board. And you know that what's happening in India right now, air quality is really not in Chennai, but of course in New Delhi, there's a big problem in air quality. So we have to have some kind of devices that always trying to give the probe, reduce the risk of illness and absenteeism, the proper CO2 levels. Nobody at home, I have my air quality, but if you're thinking about the global level, I'm getting, when I start my car, I'm the first thing I will get what is a CO2 quality. Even at my basement, I have my air quality system. It's not trivial, it's very important because I'm living in a basement. I cannot work beyond a particular CO2 level. So this should be monitored. Imagine when apply this air quality in a big, I don't know, an hospital or school system. This should be monitored, right? So we have to ensure a pleasant working environment. This is called smart. So we have to satisfy the customers to say that you are living in a good oxygen level. And if something happening, you will get notified by SMS, any warning or email, so on and so forth. And this thing's one more application. And in case of any failure or in case of some device problem, you are going to allow someone locally to control the device itself. For example, you can be able to change the lighting, set temperature, monitor CO2 level by giving a QR code. Not everyone can be able to do that, but we are going to give some particular rights to some people to alter the environment. But now I can put whatever I want in the paper. How to do that? What we have seen so far is smart city, how it helps to using, like a simulate in the using digital twin. But how can we achieve this? Imagine that once you have the data, you're talking about this intelligent agents. So I hope you are so good in machine learning and AI. There are kinds of multiple kinds of a learning system here. I'm going to focus supervised contrastive learning. In the coming slides, I also talk about why I go for the particular learning mechanism. It enhances by focusing on similarities and differences in noisy data sets. Once we retrieve a lot of noisy data sets, I have to find the similarities and differences between the data sets. So thanks to my supervised contrastive learning, so there are a lot of tools we can use. PyTorch is a very efficient tool that gives all the libraries that can do that. Then second thing, I'm going to use federated learning for decentralized data. I told you in the starting point of the class, the talk, the resilient, when you're talking about the data, we have to ensure the data privacy. So this will help to train models collaboratively across many cities and sorts without transferring the raw data. As I explained that if I really want to monitor something about the hospital, I don't want the patient data because I am going to deviate the data privacy. In this case, I really used to go for federated learning for decentralized data. Google's TensorFlow is a really good tool to do that. And there are some natural components, technology components, you can use it. For example, OpenAI GPT models, you can use NLU, and also Neo4j, the knowledge graphs. This is a very famous tool for integrating cross-department data. And now we have AP integration. So when you really want to plug in all this kind of Google Colab, a lot of API that's supposed to implement all this possible. Now there are some emerging research happening in this particular area. If I really want to have a noise resilient models, I'm again mentioning resilient. Keep in mind there are four main features. Resiliency. So NVIDIA's Omniverse for building this environment with realistic noise factors. If you don't have the noise factors, whatever you build the model will not produce the accuracy. Yeah, I told you that. So we have to simulate the real time, the noise factors. And also Waymo and Tesla's AI systems. Now we know that in North America, we have a Tesla car, the Carla. There are some driving simulations you can be able to navigate in noisy environments as well. So you can go on, I will send the slide, go and focus some of the papers that will talk more in detail about how they do that as well. And finally, now we have talked about the problem, how we are going to focus the problem. Now, what's the solution to do that? As explained that I have taken contrastive learning because it trains models, as simple as that, to differentiate between noisy and meaningful data points. I say meaningful, that will give some data for action, but I want to differentiate between noisy and the meaningful data points so that I can able to improve the robustness. Look at the keyword robustness. So I can able to believe that system will give you a sustainable solution or a more accurate, of course not 100%, at least optimal solution, so that I can able to reduce the false negative, false positive as well. So there are some implementation steps. I have some slide, I have some picture. I'm going to collect some labeled, unlabeled data sets with the real world lot of variability because constantly changing. Then I'm going to apply contrastive learning to train models. Okay, and also I try to find dissimilar patterns. This is also very, very important. So once I get that, I'm going to incorporate noise augmentation so that I can able to simulate in real world sensor inaccuracies. And that's the thing. The second thing, once I have the model, I'm going to create the virtual replicas to test and validate the AI models that just I built in the previous step. So you're going to build a small kind of a tool in NVIDIA Omniverse or Azure Digital Twins, simulate various conditions, weather changes, traffic surges, sensor malfunctions. You can think about different kind of, like a constant changing variations and continuously update with the real data with IoT sensors. So we are going to understand what could be the expected outcome, and you will see the changes in virtual replica so that we can able to apply in the real world deployments. And we build the model, we replicate in the twin, But also we have to have a continuous feedback and adaptation. That's the thing I told in the previous slide, right? So enable models to adapt to changing, evolving, constantly improving urban condition by integrating tools to monitor carefully. That's one of the more important features. How can do that? So we can be able to deploy federated learning frameworks. That's what we have a multiple technology in the pipeline, like streams, you know the streams, right? So deploy federated learning frameworks to allow decentralized updates, because I have to think about the privacy as well. So once I have to integrate multiple feedback loops, I can able to feed new insights back into the tracking pipeline, just stream pipeline. Why expected outcome could be a reduced model drift. So I am not worrying about the privacy. I'm going to get multiple sources. My model built is not so drifted, so that I can be able to adaptable over time. It's a constant learning process. I have given some use cases here: smart parking, urban energy management, public Wi-Fi optimization during peak hours. There are so many things you can able to come up to you in the real time, but I'm giving some of use cases. When there's no parking in case of peak hours, how can you able to manage it thanks to this model system? Energy management. These are the real problem existing, and also Wi-Fi optimization, right? And now, as I explained in the starting point of the talk, that is not the only solution. There are similar solutions using deep learning architecture. For example, you can apply GNN, graph neural networks, used to interconnect systems, and you can able to also predict traffic congestions by modeling road. There's one thing called deep graph library. I advise you people, please go and search for that. One of the beautiful tool for these days smart city building. And the transformers for time series analysis. If you know time series data, these are very essential, because it can be able to transform long-term dependencies. Okay, so you can use it also for that. And one more thing, they call autoencoders. In case of anomalies in urban data streams, it will try to find exactly different traffic patterns and power outages. So these are the tools I also recommend you to try for solving the problem. Now let's build the framework. So we talk about smart city, how to apply in the virtual interface, virtual protocol, virtual twins, then how to do that. Then the framework. The first thing is the data preparation. So we are going to take the data like OpenStreetMap, city-specific data platform. There are a lot of things you can be able to get data. And I'm going to generate also via simulations, right? As I explained, NVIDIA Omniverse, you know the tool. Then I have to pre-process like all the previous, like all the machine learnings, missing various normalized data. Then you can be able to introduce the noise for realistic any condition. The second step, model implementation. So I need to have the pipeline. I have to train the pipeline. As I explained that, use contrast to learning. You can use a particular type of algorithm to create the robust, then apply the learning with using TensorFlow, then simulate the models in digital twins. So I collect the data, then I can be able to implement the model using the pipeline. Then I'm going to apply the architecture for transformations, so that include the noise robust features, right? Finally, once I get the simulation, I'm also going to deploy and validate the model. Okay, in this case of that, I will again simulate urban systems, run the trained models, and deploy all kind of data on the edge devices, traffic cameras, smart meters, etc., etc. So once I do that, I can able to look at in the real-time scenario. For example, I can say that smart parking system, air quality conditions, so on and so forth. Now, as I explain why I'm taking this contrast to learning. So it will simply help me to distinguish between normal and abnormal traffic data, and it requires only fewer labeled data, which is often a bottleneck in large-scale smart city projects. That's another reason I have taken this contrast learning help. And more importantly, it learns continuously as new data arrives, keeping up the dynamic environment. These are the three main features why I'm using this contrastive learning help. Okay, and once I complete this model, we have to ask the system. When I say ask, we have to query the engines, the decision engine. So we have to build a kind of a query and decision engine so that I can able to build my architecture to deploy in real-time scenario. For example, what's query engines? Enable real-time data access and complicated queries across various resources. For example, I can able to send a query for that. I really want all the patient data more than 60 years old, have diabetes patient or in ICU on particular area during this particular period. So I have to go cascade in different IoT, different hospital, different zone, and have to filter the data. This complicated queries needed this query engines, right? So why it help people like the stakeholders to make better decision, okay, and less time. Once I have this query, I have to build some decision engines as well that make the data, analyze and implement the business rules. In case of disaster, what could be the main decision to solve the problem? So I need to have some decision engines. And also there are some kind of a tool we are going to focus on, that Azure SQL database, Science. These are the tools we can help to apply these query engines and decision engines. Now, finally, we are going to deploy this particular research area in real-time scenario, how to build a simulation as well. So when you look at that, how this CFL can be used to classify, prioritize, and manage queries across various departments, as explained that. So we have to think about the transparency, privacy, and also improve the quality of citizen. When I say citizen, each one should be not worry about sending the data. Now, second thing, how the forecasted queries and the technology predict issues, enable proactive resource allocation, optimize real-time operations. You are good, I'm getting the data, I'm going to model thing, but the predicted model, is it good enough to real-time scenario? We don't know yet. That's a real challenge, right? The third thing, now the strategies. You can say, as explained that, guys, it's very trivial. All the researchers like us, we can write so many papers to get size Scopus. Are we applying in real time? No one. Am I right? So I can talk about all the beautiful models, put all the graphs, but in case of real time, or is this secured, is it scalable, or going to leverage the agents? These things are the matters. So what I did, thanks to the professors, I was working with SRM as well. Some of the professors, we are collaborating together to talk about some of this algorithm to find a framework so that I can able to optimize all the problems which I mentioned here. There are also so many problems. I don't want to talk about a lot of the problems. It's a bit boring. So I have minimized the problem exploration. The first thing, we are using, I don't know how many of you know this SBIRT algorithm with simple contextual learning. So I have a framework here, guys. I will just talk about the framework. I don't want to get so much of bored. So the first one, this SCL features to identify similarity, dissimilarity among the queries. Why queries? As I explained in the previous slide. In case of disaster, in case of emergency, I really wanted to write a query to take the data. In this case, once I get the data, I have to identify similar and dissimilarity among the queries for the devices, right? Then I have to use GraphQL query resolving mechanisms for generated queries. So once I get the query, I wanted to resolve the efficient query so that I can be able to optimize that. There are so many technology you can use it, that simple agent program mechanism, and also multi-agent retrieval augmented generation. I hope you know that hypothetical document memory principles. These are a pretty, like implementation level. So finally, I will apply all things in the dashboard. So the dashboard is here. So once you have the dashboard, I showed in the previous slide, you can be able to visualize all the kind of queries and you can be able to deploy in your dashboard for the stakeholders. Okay. Now look at that. I have a query data receiver. You have to extract the query. Then you have to pull the using GraphQL. then the single agent using RAG, and have a multi-agent so that I can able to present and visualize and access all the data to the particular stakeholders. Efficient, secure, resilient, and robust. So when I use all this technology, I'm not going to get 100%. At least we are nearing 100%, removing the trivial errors, right? Okay. So I've taken 40 minutes, guys. Any questions so far? Uh, if anyone has some doubt, if you really want some more definition or more, I can able to explain. Is it all good? Okay. So let's talk about what is bidirectional encoder reconciliation. It's a kind of pre-trained model that uses Siamese and triple network. Main purpose to derive meaningful sentence. That's the idea. So I'm using this technology to derive the meaningful sentence. Okay, and using the cosine similarity, you can Euclidean distance. These are the mathematical ideas. Once I have that, what I'm going to do, I am going to gather, pre-process the query data, labeling pairs as similar, dissimilar, the first point. Then convert the queries into vector embeddings. The third part, I have to define and concise what is similar and what is dissimilar. Finally, I have to integrate this learning process to improve the similarity measurement. That's the first thing using this bird. This is helpful for me to distinguish the difference between the noisy and the real-time data. Second thing, once I have that, I'm going to use GraphSQL to improve data access problems, because you know that, right? So I have to retrieve dynamically from multiple resources. This GraphQL helpful to find, collect, resolve this process. And explain that the third one is go for single agent programming mechanism with RAG, enhances the generation and the decision making through dynamic retrieval systems. Because as explained that we need to have a query engines also as a decision engines. So once we have the data coming from the GraphQL, I have to enhance the generation and operates in multiple agent framework. Okay, so agents make decisions like agents, you know, all this kind of agent that have this own informational database that can able to give its own decisions based on the retrieved information. Now I have given more about what's retrieval augmented generation. Normally is a kind of a system on pairwise scoring to retrieve relevant context. When I feed a kind of a data to a particular system, I'm going to give some scoring on a relevant content, then that fed to the LLM, large system management. Then several question answering systems implicitly find and evaluate the relationship between the questions and also the potential answers. So once I have that, the system will help to rank the most suitable documents for the given query. Okay, it's very simple technology. You know that if we put RAG, that's the thing, we are going to focus on that. Finally, I have the more detailed RAG architecture retrieval system responsible for fetching relevant information from a predefined knowledge base. Then generation model is a fine-tuned TLM, takes information and generates a coherent response. And finally, there are query analyzer, retrieval manager, generation controller used to find a adaptive learning model. So I have given all this operation of the particular agent responsibilities as well. Once I have container comes from the single agent, I'm going to apply in the hide. So what is hide? Is one of the most transformative solutions to tackle poor retrieval from the RAG based. RAG is good, but it's not so optimal. So I have to apply one more layer hide that will try to eliminate all the problems caused by the RAG. And that's it. So I have given why hide. It effectively retrieves relevant documents without needing relevant labels or prior training. So in this case, I go for the hide. and generating hypothetical documents even if the details are inaccurate. The name is hypothetical. Even the details are not so precise and inaccurate, you can still go for the hide model and versatility. Okay. So that is how I'm going to give this particular architecture here. Whatever query input generate, then generate hypothetical document, then embed, finally search and retrieve the similar answers for the particular data. So I'm end of the slide. I'm giving only 45 minutes. I use the support system, GraphQL, RAG, agent, and find and hide. Once we have that, I'm going to simply apply. I'm going to collect all the queries. BERT will be used for contextual learning. Then I'm going to disintegrate. I'm going to distinguish between a similar dissimilar anomaly. I'm going to give us a GraphQL. Then I'm taking only partition data, label data. Then output could be persisted and generated queries. Then when I give to this RAG, I'm going to give the more responses like different kinds of scenarios. Then I'm using this hide so that I'm going to get the more precise output. So that is my conclusion. The idea of this entire the presentation is about resilience. Okay, I'm not saying use only this algorithm. These are the one of the algorithms we are working together to implement this idea in real time. But you go for the graph or neural network, or also one more thing called auto decoder as well. And thanks for giving this great opportunity. And I'm ready for the question. Thank you. Sir, I just completed my presentation. It's like 40 minutes.
Yes, sir. Yes, sir. Any questions from audience? Hello? Hello? Thank you, sir. Thank you so much. Very nice presentation.
Delegates shall ask any questions if they want.
They don't want maybe a comment, maybe a discussion. It's not only relevant to the question. I know that some of the slides are more implemented in details. You don't need to understand the concept, but I'm focused more on the problems and how to solve the problem. It's not how, it's what, how can you able to sustain a solution for the problem. That is the main intention of this presentation. So if you really want to give some comment, if you really want to discuss, if you want to take it further, I'm happy to give my feedback. Thank you.
Thank you, sir. Thank you, sir.
Okay,
Thank you so
even
much.
afterwards, you can send a mail. We will share mail ID of professor.
Yes. Okay.
If you need any clarifications, you can
Sure.
ask him.
I'm
Thank you,
happy
professor.
to.
Thanks for
Thank you,
joining
sir.
us and delivering an excellent lecture to the delegates of this RASTEMS 2024. Thank you, sir.
Thank you
Thank
so
you,
much.
professor.
Have a good one. Take care. Bye.
Thank you. Professor, the next session speaker has come.
Yes, sir. Yes, sir. Niveda Martin, madam.
Yeah. You can start now.
Yes, madam. Madam, are you there?
Yes, sir.
Yes, madam. Welcome, madam. Welcome.
Good morning and welcome, Dr. Niveda Martin.
Thank you, sir. Thank you.
Madam, 1 minute, madam. Let me introduce, madam. 1 minute.
Okay, sir.
Okay, very good morning to all. Our second invited talk person, Dr. Niveda Martin, is presently working as an assistant professor in the Department of Mathematics, Arlo Andar College, Parmathur, Madurai. She has completed her integrated undergraduation at Pope John Paul II College of Education affiliated to Pondicherry University. Postgraduate at Holy Cross College, Trichy. She has conferred her doctorate from Bharatidasan University. She has project fellow in UGC major project at Holy Cross College. Um, she served as already assistant professor at NPR Arts College, Dindigul and PSN Engineering College, Dindigul. Adding her credential, she has completed master's degree in management, sociology, psychology, Christian studies. She has qualified set both in mathematics and management. The She has completed around 15 NPTEL courses. Her areas of research are inventory modeling, fuzzy cognitive maps, nutroscopic and cryptogenic theory. She has produced 7 MPhil and 2 PhD scholars. She has published more than 100 articles in reputed journals, presented more than 50 articles in conferences, has prepared more than 50 video contents in different fields, especially in programming languages and software such as R, Python, and SPSS. She has received 2 patents. She has presented papers at international conferences held at Kuala Lumpur, Malaysia in 2019 and Sri Lanka in 2023. She has also received UGC travel grant in 2019 and student project TNSCST in 2022. Also, ma'am achieved a lot of awards, a lot of things are there. Madam, please take over this session, madam. Thank you so much, madam.
Thank you, sir. Thank you so much for your introduction.
Thank you, madam.
So, hope the slides are visible.
Yes, madam. Yes.
Yes, sir. So, uh, first and foremost, I'd like to thank the organizing committee for giving me a wonderful opportunity to present my some research works and also my own research area in this international conference. So coming to the mathematics domain, because this conference having a multidisciplinary domain, so with a special reference to mathematics, I'm so happy to deliver a lecture on plethogenic decision-making models. So we'll have an introduction to plethogenic sets, and I have just streamlined the presentation like origin of plethogenic sets. We'll discuss something about the classification of plethogenic set operators, and the exact applications of plethogenic sets in multi-criteria decision making. So we know for sure that the whole world is actually filled with uncertainty. So everything is actually, if it is going to be deterministic in nature, then decision making is not at all a problem. It is going to be a very simple task and it is going to be a very piece of cake. But it is not so. We know for sure that whatever the decision making situations we are going to discuss about, the uncertainty actually comes into an uninvited member or element into that scenario. So here we are actually trying hard a level best to compete with this uncertainty with the different types of representations. So this is actually I can tell you both mathematically and even in a more explanatively I can give you an understanding about the different kinds of representations that what we are discussing or what we are dealing with our day-to-day research works. So when we talk about the crisp set, no, and we know that whenever there is uncertainty is presenting, we are moving towards fuzzy representations. So people are very well aware of the deterministic as well as fuzzy, all the domains, irrespective of mathematics. When we just start dealing with engineering people, when we start dealing with the computer, and all of them know they start discussing with the deterministic, and from deterministic they are moving to fuzzy. So these are the two common representations we are discussing in a decision making environment. But when coming to the other extensions, maybe on one side you will be able to find just a set 0 1, and then you will be having an interval then another one interval of order 2, then another one interval of order 3. So you will mathematics people can able to understand, but when people of other domains, I like just to come back to the next one. So now we'll discuss about what is crisp, what is fuzzy, and from fuzzy there is an extension to called intuitionistic, and from intuitionistic we have an extension to called newtoscopic. So I strongly believe that nowadays the concept of newtosophy is also gaining a lot of momentum, and many people are having their research areas shifting towards a newtoscopic logic. So we know that these things are most commonly used representations, and the mathematical representations are given on the other end, but all these two together. So I have just put a common brace to encompass all these set representations, and have given the term called pathogenic set. So I think this slide itself will be giving us a very vivid picture of what is pathogenic set. So it is a generalization of our crisp, fuzzy, intuitionistic, and newtoscopic. So this is where the pathogenic set is getting originated. So I like to just give a very small example, because not all of us are familiar with these kinds of representations. And as you are just looking into the simple examples, we'll be able to understand the need of these representations. See, the crisp set or the deterministic set, no, they are the base of the mathematical foundations. And now I'm just taking a universal set. Always we term X to be the universal set, and from the universal set we define a set A. Okay, so I'm just going to take my universal set across all the kinds of representations to be set of students in first BSc mathematics, if that is the case. Now I'm just going to take a set to be set of boys in the class. It's a simple one, no? Because it is students and I'm taking the boys in the class. And look at the membership function. So it takes the values either 0 or 1. It is binary. So this is what it is, a representations what I was just having at the other end. So this is, I can say, it's a mathematical implications of these sets. Now coming here, if I say Ram, can I place Ram in this set? Yes, of course. So he gets a membership value 1. And can I place a person named Ganga? Maybe no, because it is not actually a boy and I cannot place this set. So it's very simple. So either a boy or either a girl, it happens like this. But then look at the fuzzy set. It is introduced by Lofty Zadok in the year 1965. I can say the crystal set, the George Cantor is actually the
சொல்லுங்க
originator,
மேடம்.
the pioneer. So now moving on to the fuzzy set. Now look at how I'm defining the set. I'm defining the set to be good boys in the class.
சரி.
So now CRISP is dealing with a quantitative set of boys. It deals with a number. How many boys are there in the class?
டேட் வந்து ஞாபகம் வச்சுங்க மேடம், எல்லாம் பிடிக்கிட்டு போயிடுவாங்க. அதோட ஃபைன் போட்டுருவாங்க. 100 ரூபாய் 200 ரூபாய் 300 ரூபாய் ஃபைன் போடுவாங்க. ம். ம். சரி, ஓகே. கட்டலைன்னா ஒன்றும் ஒர்க் கடை முடிவாங்க.
Sir, I think we are getting some more
சரி.
voices.
ஃபோன் பண்ணி சொல்லிடுங்க மேடம், ஒன்றும் பிரச்சனை இல்லை.
So now moving on to the fuzzy set. So fuzzy set is actually dealing with a qualitative aspect. So qualitative aspect in the sense, we talk about good boys. But you just look at the set of fuzzy. We are placing Ganga also here, but we consider the membership value to be completely 0 and look at the membership values. It takes between the interval 0 to 1. So Ram is actually a member of this particular fuzzy set with a membership value 0.8. Ganga is also one element of this fuzzy set with a membership value completely 0. See, but the previous one, we couldn't bring Ganga into the picture. We couldn't take Ganga as an element of the set because it is a crisp one. But whereas we brought Ganga into the set representations, and we are giving membership value as 0. So look at this then, an advantage of fuzzy set over the deterministic or the crisp set what we have when we deal with the qualitative. Now when we deal with the intuitionistic, it is Atensov in the year 1983. The same set defining. We're not going to change the way we are defining the sets. It's a set of good boys. But here we are having a few things to be understood. One is actually membership, and other one is a non-membership. So what I mean by membership is it attributes to the degree to what that particular element or a member is satisfying the nature of the set. So on what the way we are defining the set, to what extent it is satisfying the set, and non-membership to what extent it is not satisfying, and sometimes we'll be having the indeterminacy, and that indeterminacy is being computed as 1 minus of the sum of these two, membership and non-membership, and we assign these values to have the sum to be less than or equal to 2. And now we have membership to be again 0 1, and non-membership also 0 1, and that's why we are having it is actually the closed interval 0 1 the square, that is raised to power 2. The order of this is, so it is a 0 cross 1 interval, and again it is a Cartesian product. Okay, so it is a double cross of what your interval, closed interval 0 1. So now look at the value of Ganga here. The membership is actually 0, and the non-membership is actually 1. And the sum is actually is going to be 1 here. And the same way here also is going to be there, and here also it is going to be here. So now this I can say that this intuitionistic fuzzy set is actually a generalization of our fuzzy set. And now here comes the other advanced version of all these sets. It is a nutoscopic, and this is actually attributed to the great person Florentine Smeranda, and he is a nutoscopic researcher, and he has contributed a lot to this nutoscopical arena. So in the year 1998, he just started to go with indeterminacy as a separate one. So whereas intuitionistic, it is actually classified as a difference of one from the sum of membership and non-membership. But here he is accounting as, again he is defining the indeterminacy as a separate function. Like as he defined the truth and the falsity. And the sum will be less than or equal to 3. And that's why we are having the closed interval 0, 1 order 3. So now this is a very simple example here. And now if you look at Ganga alone, so what is that 0. 0.8, 0. 0.1 and 0.1? See, if I'm just going to ask whether Ram is a good boy, sometimes I can say 80% that may be a chance. So 10% maybe I'm not able to sure certainly say that yes or no. And 10% there is no chance at all. So this is a way, practically whenever we make a decision, so whenever we are going to choose an alternative, or whether we are going to see that whether it is satisfying few criteria or not, we are not 100% sure whether that particular alternative will satisfy the criteria 100%. If it is satisfying 100%, it is deterministic. So when there are plus or minus, when there is an not probably we are able to say rightly, then automatically we have to take different sets representation. So now nutoscopic set is a generalization of your IFS. So once we say nutoscopic is a generalization of IFS, then obviously it is a generalization of all the other kinds of representations. And now there are other extensions are there. So it is not only we have the fuzzy sets with the representations. We have single value, we have multi-value, we have interval value, we have bipolar representations, and we have hesitant, fuzzy soft sets, and so many sets are there because they are the other branches from the main root of your fuzzy sets. And now here comes the core part of our talk. It is actually the plethogenic sets, and this is also developed by or introduced or coined by the Florentine Smeranda in the year 2018. So I could say that it is only 6 years old, I can say. And now, how you can generalize it? Whether you are going to have a 4, that is 0, 1, power 4, or something like that, you are going to do it. No, it is not so like that. It is a different way of considering a generalization. Now we will see why and how it is. So when we talk, what is plethogeny? So when I say plethogenic sets, when I say nutoscopic, there is a theory called nutosophy. From that only we have the nutoscopic logic and nutoscopic sets. So when we talk about plethogenic sets, and we need to know what is plethogeny. So plethogeny has different meanings. You can say it is an genesis, that is the origin, and it's a formation, it's a development, it is an evolution. So in so many interpretations are there for the word plethogeny. And now what is the plethogenic set? So plethogenic set is actually, we have it as P, and it is more categorized by attributes. So it is, I can say it is contributing to, or it is attributing to, the attributable theory will be there. So much of it is attribute centered. Now, attributes are nothing but, I can say it as features, what we talk in the machine learning language, or when we talk in MCDM language, we can say it is a criteria. Or generally, when I want to address it, I can put the word called attributes. And now these attributes are having attribute values, which will be explaining shortly with an example. And now the other two major parts is actually the degree of appurtenance, and we have the degree of contradiction. So when I talk about the plethogenic sets, it is actually a quintuple. You have P, you have an attribute A, you have an attribute set V, that is it, all the values concerning to a single attribute. Then we have D, it is a degree of appurtenance, and C, we have the degree of contradiction. So now this is what I was just telling you. It is a quintuple. You have a set, attribute, the range of attribute values, the degree of appurtenance, and degree of contradiction. So if I want to define pathogenic set, I need to have all these things. Only with this, I can proceed with the conceptualization of the pathogenic set. Now, what is an attribute? As I was just telling you earlier, it is a quality or it is a characteristics which describes a person's or a place or thing. So that is actually the attribute. Literally, what we mean by the word attribute. And now, see, now a person is just looking at a box. Okay, when you just look at the box and you want to describe this box, so on what all aspects will be able to describe this? So generally, the size. Suppose when we want a person to pick a box, we say you pick that small box, you pick that large box, you pick that medium-sized box, and the shape. So the boxes can be of different shapes, and the boxes can be of different colors too. So these are the general attributes when you look at the box. So whenever if someone is asking you to describe box, we generally describe with the size, with the shape, and with the color. Generally, okay. So now in a general aspect, we take these are the attributes. And now, what are the attribute values? So when I take size, I can go with a small, medium, and big. When I go with the shape, I have different attribute values. When I take color, I have different attribute values. So this is the difference between attribute and attribute values. So A is nothing but a single attribute, and V is nothing but the range of attribute values. So now talking about the attribute and attribute values, I hope it is clear as of now. And now what is degree of appurtenance? To explain it, we need to know what is your P. So P can be different types of boxes. No? We have it as a set comprising of boxes. So there are 5 boxes of different sizes, different colors, and some have also different shapes also, maybe they. Okay. So now when I take attribute size, okay, I consider the size to be the attribute. And what are the attribute values? So it can be small, medium, and big. Now, what is this attribute values is, it is V1, V2, and V3. So now, what is the degree of appurtenance? So the degree of appurtenance is nothing but, it is a value which shows or which indicates or signifies the satisfaction of the element of the set P with that of the attribute value. So now the degree of appurtenance, I just always know concerned on the dominant attribute value because it is more important. I cannot be considering all the sizes of the particular boxes. I will be very much particular whether I want a medium size, whether I want a small size, whether I want a big size. It depends. So it has been left to the choice of the expert. Now, the expert says that this is actually the size of the box that is preferred for packaging. It is the size of the box preferred for times of manufacturing. So it can be anything. Okay. So the expert's choice of the size attribute values is very important, with which each of the elements of the set, okay, in the P, to what extent it is satisfying. That is actual degree of appurtenance. Suppose if my attribute value is big, okay, to what extent this x1 is satisfying the attribute value of big. to what extent this xy is satisfying the attribute value of big, because this attribute value which is dominant is my own choice, that is the expert choice, the one who makes a decision. So this is a degree of appertinence. And now what is the degree of contradiction? So degree of contradiction is between the attribute values. It is very important. So degree of appertinence is between the elements of the set with that of the dominant attribute value. And the degree of contradiction is between the attribute values. Now if I'm going to consider, okay, small to be the dominant attribute value, so what is the contradiction between small to small? It is 0, because small is actually considered to be the dominant one. So dominant attribute value is actually small here. So small to medium, it is going to be 0.5, and small to big, it is going to be 1. So this is a very simple way of understanding a plethogenic set representation. So this is the inclusion of the contradiction degree as well as the inclusion of the appertinence. Now, how do I say that it is a generalization? See, the degree of appertinence is very, very important, because look at that. This Z is going to be a value which is going to assume 1, 2, and 3. So if it is simply, if it is going to assume 1, it is going to be a fuzzy one. If it is going to assume 2, it is going to be actually then intuitionistic. If it is going to be 3, it is going to be neutoscopic. So this is how we are able to get actually the plethogenic set to be the generalization of your crisp, of your fuzzy, intuitionistic, and neutoscopic. And now we are having the classification. So I believe that we'll be having a better understanding about what is plethogenic set. And now we'll move on to the other part of it, the classification of plethogenic sets. See, now we have a set called refined plethogenic sets. So what is the meaning of refined is when we are having a refinement of attribute values, so many sub values. So when you take one attribute, it is going to be small, that is the size. Then you have attribute values. Then each of the attribute values have sub attribute values. Then we call it as it is a refined plethogenic set. So that's why we have the notations called PR. And this is a quite interesting one. So plethogenic overset, plethogenic underset, and plethogenic offset. So this is also an extension of Florentine Miranda contribution. So overset means it is actually the value is going to be exceeding 1. You call it as it is actually an overset. And sometimes if it is less than 0, it is going to be underset. And sometimes when you have the both the combinations, you call it as plethogenic offset. So these are the some growing areas, the real possibilities of how a membership value can be less than 0 and at what instance it will be greater than 1. So these are under research works it's going on. So we have different representations. And now plethogenic multiset. So plethogenic multiset, when you deal with a 1, you call it as a single valid 1. When you deal with too many other sets, you call it as actually a fuzzy multiset. That is plethogenic multiset 1. And now this is the one here. So when your degree of appertinence, so it is actually P cross B. When it is going to be a crisp set, look at the representation. And look at the representation if it is going to be a fuzzy set. And if it is going to be an interval valued one. So when it's going to take an appertinence degree between some range of values falling within an interval, you call it as interval valued. And this is a simple example I just want to say. When you deal about a single attribute plethogenic single valued fuzzy set, so many single is there. So you are going to consider only one attribute value, and you are going to consider a fuzzy set representation of appertinence value. So this is a very simple one. So look at the attribute values. Now you can keep on increasing the attribute values. Now this is, I'll be taken a small, medium, big, and very big. Even you can take small, and you can take it as bigger or something depending on the situation of decision making. You can just take, and accordingly you can assign the degrees of contradictions and degrees of appertinence. So it's only an instance. And now here comes a by attribute. So So by attribute, there are now two combinations. One is the color and another one is the height. Suppose if I'm just going to take. Now color and height, look at the various combinations. So it is a Cartesian product like. So we have different combinations with the green and tall, yellow, tall and red. So many combinations of it. I'm just going to take. So out of the possible combinations, we will take the green to be the dominant one, and the height tall, that attribute value can be the dominant. Now look at the conjunction. So the conjunction degrees is falling between the respective attribute values. And now we are given one expert. So one expert is giving the values of conjunction degrees to be like this, and here it is going to be the aptitude degree. And we have another one expert, and he is also giving such kind of representations. Now how to get a unified representations? So the unified representations, now we bring into picture of what the plethogenic set operators with respect to the fuzzy representations. So now look at this, we have the T norm and T cone. So it's like union and intersection, you just go with that. And look at the way they are defining it. Now this is actually the formula that has been given here. And by making use of this formula, we can just bring about this particular result. So now this computation is very simple because we are just going to apply into this formula what is a conjunction degree and what is the degree of appurtenance with respect to A and B. So this value is be there. So A, B. So for each of the combinations we are going to get, okay, because we have different combinations. So XC and XB is there. So out of 0.6, 0.8 and 0.7. So how to get these values? So maybe I go with the conjunction, what is falling on with that. So what is your expert, and this will be our AB, and this will be the conjunction of your CI. So what is with that? So this is a very simple one, you can do it. So computation is not a big problem. When we have a formula and we have the values, we can simply substitute and get it. But how to take it to the other ways? Now this is a finalized one. So the two experts are there. It is their union and it is their intersections with that. So union intersections both are is dealing with that. And here it is a reference what is given from this particular paper, because this is actually the base of this plethogenic. Now moving on to the next part of how we are going to apply it. Now this is actually the work that has been evolved in 2020s. Plethogenic sets and multi-criteria decision making. So before venturing into this, so far we have just dealt with the degree of appurtenance. And this research work is actually developed by me in collaboration with Florentine Miranda. So when we are discussing about that, why can't we go with the degrees of conjunction? Because every time we are focusing on degrees of appurtenance. So what will happen to when we bring the degrees of conjunction into the major picture? So that's actually an idea. So it's a novel way, and this particular approach is gaining more momentum at recent times. And many recent works are actually based on this conjunction-based decision making, because all of our objective is to minimize the conjunction. So we'll see how that degree of conjunctions is exactly applied in developing such an MCDM, and it is a novel MCDM approach, and it's a simple MCDM approach too. See, when you take MCDM, it's a very big ocean, I should say, because so many methods are there, and those methods are actually innumerable in number. Because it is not dealing with only one aspect; it is dealing with so many aspects. So there are major methods are there. One method will be used to find the criterion weights. Another method is used to be find the ranking, and some methods that actually goes hand in hand in finding the optimal solutions. So when we talk about MCDM, it's a very interesting arena of research, I should say, because it really dwells with the real life applications. So I want to make a decision. I need alternatives. Suppose if I want to choose a job, I have three jobs in my hand, which I want to choose. I have many criteria to be considered. First one will be salary. Another one is a company, because whether the company will flourish well or whether a reputed company or not, because it shows about the consistency and job security, and also whether it is proximal to my home. That is also important. No, it doesn't mean that I want to earn much. I cannot leave my family and go somewhere, and I couldn't travel every day 2 to 3 hours just for the sake of work. So many aspects are there. So these are the criteria. And alternative is three jobs. So which job should I choose? So you have in a company aspect, when you decide, there are so many suppliers will be there. Which is the best supplier? To whom I can place all my orders? So many aspects are there. So the decision making is a very, very interesting arena. So now, what are the steps involved in pathogenic based decision making? So I have to define what is a problem. Finding the criterion weights is very important. Then I want to construct the contection matrix. Then weighted contection matrix I have to compute. Then finding the score values. Then I have to rank the alternatives. If you look at it, it's only a 6-step problem and it's a very interesting one also. Now let us just go with the application of this
Ma'am,
DMPC in supplier, because it is a decision making based on contection, pathogenic contection. So we
madam,
just have a acronym of DMPC. So let us just consider a logistic supplier selection problem. We have 5 alternatives and 4 criteria. So look at this. It's a very, very common criteria in any manufacturing industries, or this is a quite common. The price is very important. So what will be their delivery time span? So whether they're flexible, whether they're reliable. Because sometimes you will place sudden order, sometimes you'll be having delay in payments. So the supplier must be flexible adjusting to your returns. So those risk factors also very much consider. Now we have to just categorize this criteria to be
madam,
benefit criteria.
ma'am,
Yes, sir.
madam, please take 5 minutes, madam.
Yes, sir.
Okay,
Yes.
thank you, madam.
So we'll have this categorizing into the benefit as well as cost. So we will have the respective values over here. So this is a context criteria that what we are able to do it in generally. When we take low to be for dominant, or high to be for cost, so we respectively have it. So we have the construction of the decision making matrix. Then we have the criterion weights to be computed using the methods, and we have the context matrix over here. So we can find the weighted context matrix. It's very simple as usual. And now we have computed the score values of cost and benefit. So when we have the difference between these values, and we can have the ranking of these values. So now this is actually not depending on the degree of apprehendance, but it's based on degree of conviction. That is a novel approach that what we have been conceptualized in the arena of decision making. And this is another one extension of external pathogenic sets. So extended pathogenic sets, I think, but last we had a quintuple. So here it is actually septuple one. So we have both dominant and recessive attributes. So the previous method, what we discussed, that given rise to another one kind of representations called the external pathogenic sets, and the applications are also now in growing arena here. So this is actually an extension of how pathogenic sets can be applied or can be leveraged in decision making. So at the closure of the, this lecture, I like to just have a revamp of what we have done it. So we have just discussed about pathogenic sets, the classification, operators, and its application, and also the extensions. So I thank the organizers for giving a wonderful opportunity to share this excellent idea of research. Thank you, sir. So if there are any queries or any points to be discussed, we can. Otherwise, I think we can end the session, sir.
Madam, very nice presentation, madam. Veda, madam.
Thank you, sir.
Another invited person waiting, madam. That's why I close it.
Yes, sir. Yes.
Okay, madam. Any other question from audience? Hello, hello. Okay. Madam Geeta, madam, are you there?
Yes, sir.
Okay,
I'm
madam.
there, sir.
1 minute, madam. I will introduce yourself, madam. 1 minute.
Sure, sir.
Okay. Dr. Geeta is Welcome, madam. Geeta, madam. Welcome. One
Thank
minute.
you, sir.
Thank you, madam. 1 minute, madam. Dr. Geeta is currently working as a professor, MTech coordinator, and academic monitoring committee in computer science and engineering, KLE Institute of Technology. She established the intellectual IPR cell in KLE IT on 11th June 2020. She received her PhD in computer science, Jawaharlal Nehru Technology University, Hyderabad, Telangana, India. She has 29 years of teaching experience. Her area of research includes data mining, system software, image processing, computer network, and distributed databases, big data analytics, blockchain technology, cloud computing, etc. Her PhD research work is in the area of data mining, a novel hybrid model of web pages categorization. PhD research scholars awarded are three. She has published 73 papers, 46 papers in international journals, 21 papers in international conferences, 6 in national conferences, seminar, published so many patents, some grant also ma'am got, sanctioned with the grant of 15 lakhs for the project, AI based system on MSME from MSME, sanctions with the grant of another 6 lakhs for the project title cloud based mining data diabetics data for early prognosis and diagnosis in the disease management, funded by VTU University Belagavi, research grant scheme, and rupees 5 lakhs for data mining and data warehousing, funded by AICTE. She acted as a head of the department IT and Master of Computer Applications, GMR Institute of Technology, Rajam, Andhra Pradesh, India. A member of Board of Studies, Board of Examination, National and International Advisory Committee, Editorial Board, and Editorial Board of International Journals, and reviewers of various reputed journals of the international and international level. Thank you, madam. Very welcome to New Rhine. Madam, please
Thank you very
take
much,
your
sir.
reception, madam. Please take it, madam.
Thank you very much for giving me this opportunity. So I'll be sharing the screen, sir. Am I audible, sir?
Yes, sir. Sir, Vinay, sir, just 15 minutes, sir. We will start, sir. First invited person, 15 minutes has taken extra, sir. Just 15 minutes, we will start the session, sir.
Okay.
Yes.
Okay. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you. Thank you, madam.
Thank you, sir.
Okay.
Sir, can I share, sir? Or
Yes,
after
yes,
15 minutes?
yes, madam. 15 minutes, please. You
Complete. Okay, sir.
for your outline, madam. Research outline.
Yes, sir. Yes, sir. Sir, is it shared, sir?
Yes, sir. Yes, madam. Yes, madam.
Yeah, good morning, everyone. I'm very happy to be part of this international conference on recent advances in science, technology, engineering, management, and social science. So, my topic is exploring web mining opportunities, challenges, and future directions. Sir, is the screen visible, sir? Next slide.
Next slide, not moving, madam.
One second, sir. Uh,
Yes,
now,
madam.
sir.
Yes, madam. Now it is okay.
Okay, sir. And today's agenda is I'll be covering with web mining introduction. What is the need of web mining? What are various opportunities and challenges? And how web mining is different from data mining? And classification of web mining techniques. We have with mainly three categorizations: web structure mining, web usage mining, web content mining. So, as all of us know, every one of us are using internet nowadays, mobiles nowadays. So, the website statistics report of 2024 says this is a global internet usage statistics. At the start of 2024, there were approximately 5.3 billion internet users worldwide. That is around two-thirds of population are connected globally to the World Wide Web. So we'll see what this World Wide Web is and how it is playing a important role across various technologies and supporting various services, providing various services. So China has the biggest number of internet users of any country, around 1.05 billion, accounting for almost a fifth of global internet population. The reason with the world's highest internet penetration rate is Northern Europe, where around 97 out of every 100 people are connected to the internet. So, if we consider like number of websites in the world by 2024, there are around 1.1 billion websites on the World Wide Web. Out of all the websites in the world, only 200 million websites are active. So this is the thing how even the website is getting obsolete and getting not used, being in the internet and taking some of the space. So it means that only 17.83% are actively maintained and visited. The number of the new websites that emerge every day is 252,000. So this is the design of website and inclusion of the websites. And if we go through this statistics, so number of the website in the world by the year. So if we see the scenario, it is 2023, around 1.6 million websites are active, and out of which the websites which are being hosted in the server, it is around 1.2 billion. So this shows the hierarchy how the websites are designed and used or visited. And these are the most visited websites in the world. Uh, the topmost website visited is google.com, where with various domains, okay, commerce domain, education domain, academic domain, right? So google.com is the most dominating and prioritized commercial domain, followed by YouTube and so on, Facebook, etc. And if we see the number of the users which are using desktop and mobile, this is shown via this range between blue and pink. And this is the statistics collected from Statista, which says this is the number of the websites overall across the world internet. So what this mining is, what is the need of mining, and why I preferred this particular problem definition. As all of us know, mining, it refers to extract something from anywhere. We have heard of coal mining, gold mining. So like this, here it is a data mining. So when as we know very well what this network is. So network is collection of autonomous computer systems which helps in performing some objective or goal, right? So data mining, it is defined as a process which is used to extract useful information for large set of raw data. So there is a data available, I want to extract a potential information, right? So is the screen shared, sir? Am I audible?
Yes, madam. Yes, madam.
Yeah. So this is the structure of the web, internet. So around billions of users are using various nodes, and this internet, it's collection of computer networks, collection of wide area networks, which is inclusion of computers, that is desktop, mobiles, routers, bridges, gateways, right? And how the data can be stored in such a big internet, which is spread across the globe. So it is in the form of hypertext document. So because of this, web mining came into picture. So what this web mining is, it is web mining. It is application of data mining, which helps in retrieval of hypertext documents from the World Wide Web. So what this World Wide Web is, it is just an information system where documents and other web resources are identified mainly through Uniform Resource Locator. So every website is given URL which is being used to get the information. So which may be interlinked by hyperlinks. So here is the situation. Even a common man is worried about what is stored in internet, that is World Wide Web, which is collection of hypertext documents, and how can I gain the knowledge from this globe, from this internet. Even nowadays, primary school student also will use a Google search engine and ask a query, and he will get the answer. What is today's temperature? What is tomorrow's temperature? Right? So this is how the information system is so closely available for even a layman, and helping in gaining the knowledge and decision making. So this is the view of mining system. So your computer system is with CPU, memory disk. Instead of storing it at a centralized server, it has been distributed across various servers. So these are the opportunities and challenges which I am going to discuss, which may help most of the researchers for any of the applications. It can be any of the domains, like it can be management, it can be even social science. Most of us are going for networking, right? It can be any of sort of applications like agriculture, healthcare applications. So it can be applied anywhere across various domains. So as web data sets can be very large, it is in terms of tens to hundreds of petabytes. So cannot mine on a single server. So there is a need of a distributed server environment, and how well all these hardware and software can be organized to mine huge data sets. So, what it should do? So, I want to find relevant information. Suppose if I give a query, what is the birth date of Gandhiji? It should give just relevant information. It is October 2nd, right? And with a year. It should not give any other information. This is one of the challenges. So, wherein we are working with semantic web, right? Still, it is under process, and creating a new knowledge out of available information on the web, personalizing the information, learning about the consumers. So even we can come to the conclusion and even interest of the consumers, which product they are very much interested in. So as such is the web mining, which is application of data mining, which helps in discovering and extracting information from web documents and services. So the main purpose of web mining is discovering useful information from World Wide Web and its usage patterns. So how it is different from data mining? So as we have seen, traditional data mining, it is structured and relational. If I take a payroll, like every employee with this salary, right? This is maintained in the form of a table, like rows and columns. So well-defined table will be there, right? Keys there. If around 200 employees are there in the institute, no, given any faculty ID, you will get the details, right? This is in the form of database. So here, but in the internet, we can't have just a structured and relational table. We can have semi-structured and unstructured data. So it is a multimedia data. Okay, this is how my Google search engine is working with, and Yahoo search engine. There are a number of search engines available. Microsoft Edge, okay, Opera, a number of search engines are available, and the web is with huge amount of information, and consumer is in need of the content from the web, and all these search engines are helping to retrieve the information. And these are the applications: e-commerce, user profiles, targeted advertising, network management, and information retrieval from the web. And these are the classification of web mining techniques. So there are three categories: web structure mining, web content mining, web usage mining. We'll see what these are. So these are the various opportunities. The much of the web information is totally linked. You can imagine now how these hyperlinks are linked. Right? Most of us are having a website. We are maintaining a website, no home page. It has with so many titles, subtitles, and every title has a link to next page. Right? And much of the web information is redundant. This is one of the challenge and opportunity also. And the web is noisy. It is a mixture of many kinds of information, and web is dynamic. Some of the content in the website can be static, It can be dynamic also. Dynamic, I want to change like little bit a schedule of a particular conference or a workshop, right? I can make only that particular page dynamic, and keeping other all information static. And this is regarding website. We'll see what this website is. It is a collection of web page. What this web page is, it is a page with HTML tags. And what this HTML stands for, hypertext markup language. So there are predefined hypertext tags available. It can be head, title, anchor, image, right? So with this, I can have a web page. And most of the web pages consist of HTML elements like table, menu, button, input box. And this is the website topology. I'll be writing the structure of web page like this. Then when I want to organize the website, it is with a BFS, DFS, or combination of BFS and DFS. And taking consideration for only pages, simple pages, no, this can be organized in this way. So there are 4 pages which are can be aligned left skewed, or it can be like a tree. Even you are with a very good number of web pages, 100 web pages, 50 web pages, no, you can think upon how these can be organized. So it can be either breadth first, or it can be depth first, or combination of both. Okay. And this is web structure mining. What this structure mining is, how web pages can be stored and how they can be linked. So it deals with discovering and modeling the link structure of the web, and it is called as topology of the hyperlinks, right? And this is a graph. It can be represented in the form of web graph. You are with collection of nodes. Every page is a node, and all the nodes can be collected through a link. I can have in degree and out degree, right? So this is just one simple example, college website. Home web page is there, and there are 2 web pages, engineering and non-engineering. Engineering, again, it is with so many department pages like ECE, CSE, ISE, something. And again, this page is with teaching and non-teaching faculty. So like this, web pages are linked with the help of anchor hypertext reference. And this is one of the applications which was done. Now you see, like the page which is at the leaf node, like teaching of CSC, is being visited more time. So when user visits your website, the head count is taken. He has to go to home page, then come to engineering, then come to CSC, then come to teaching. Instead of that one, I can bring this teaching, since it is with high hit count, high visitors visited. So I can make this home page, I can make this teaching CSC page as very near to the home page. So this is one of the applications which is done, which is implemented also, which has been under usage. Like so engineering is with the highest hit count relative access. So it is being brought as home page. So this is one of the interfaces which has been implemented. And this is the mining where all it can be applied. Social network and citation analysis, wherein you can discover specific types of pages, which are hubs, which are authorities. It is like when so all people will come to you for asking the doubts, no? It shows you are with very heavy knowledge. So you become author of that particular information, authority of that particular information. So you are given heavy weightage and the rank is very high. Why can't you be your office be very near to the entrance of office, entrance of your institute? So that is how it is being applied, right? So instead of making all the users, whoever wants to visit, going through various flows and other things, no, bring this particular person with a very high rank, high reference, very near to the entrance door. So even the application micro communities in the web. Out of all the groups, one particular group is playing a vital role. No, why can't you give a heavy rank for that particular group and bring it very near to the home page? We can avoid other log file entries. So this is one more web usage mining. So as all of us know, no, like whenever we enter library and all, no, we'll be registering log file we are entering. Right, we'll write serial number, USN name, time, in time, out time, and phone number. We'll be writing. This is a log file, right? Like that, here also, the servers will be maintaining the log file. Whichever user is visiting your server website, no, its entry is made in the log file, and this is the structure of the log file. Okay, so which IP address is visited, on which date, at what time, and what is the code, status code. We'll see what the status code is, which web page is visited, and is the status completed or not, successful or not, and how many bytes are downloaded. So this is the log file of a server. For every website, no, the server maintains this particular information, and it contains all these various files: access log, error log, referrer log, ascent log. So page popularity is one of the important terms. That is number of hits to a particular web page. Okay. And this is regarding status code. So most of us might have seen the code, no? 400, 404. 404, file not found. So you are requesting for a file which is not there in the server. There are series of codes. 300. Suppose web page, home page name is changed. Home page of a website name is changed. So it goes for redirect series, right? And 500, if there is any server error, I'll get the error related to server. Okay, 302 for redirect, 404 file not found. It is, for example, a classroom is to be conducted at LH1, some ground floor. It is being shifted, right? It is first floor, second LH, second lecture hall. So you are redirecting, you are writing on the board like it is being directed to the first floor, second lecture hall. You are sending a message like that. It is redirect, and again for that set of codes are there. It is 300 series. And these are some of the publications which are published related to the structure mining literature survey on web mining. A very rigorous literature survey is done on this particular topic. Still, there are very good opportunities and challenges in this particular area. So this is the analysis made, right? So how WSM, WEM, web structure mining, web usage mining are different, and web content mining. See, nowadays we are going for generative AI and all, no? See, given one particular word also, no, it generates around 10 pages of information. Given 10 pages of information, you abstractificate it. Okay, it is called as abstractification. So get a abstract. Around 500 pages of information is there. No, I want to write just in one paragraph. I want to give a title for 500 pages of information. So it is content mining. So here also, you give for the Google search engine some query, right? Suppose political issues or something you want to give, no? It goes through all the documents, hypertext documents which are stored at the server side, and it gives only the relevant information, related information page wise. Like first page around 10 to 12 hyperlinks are there. Next page again, next 11 to 20 hyperlinks are there. So it has been, and Google search engine, it is going for page ranking algorithm, right? And I have implemented, so this particular thing is implemented wherein I have considered web structure mining and web usage mining together. So we got very good results. Okay, it is just like one more search engine we have done. And this is the literature survey made, and it is very good literature survey for any of the beginner. And with all parameters, even not even leaving a small attribute which is potential, right? All attributes are included, and these are various parameters. So I can go for various activities. It can be web mining activity, web structure mining, web usage mining, web content mining, right? It can be combination of all these. And there are very good algorithms which are used. It is hypertext induced text searching, right? It is HITS algorithm, link editing algorithm. Link editing, it just concentrates on hyperlinks. But I have gone for combination of these two. General utility mining. See, a particular page, how much amount of time it is used. So suppose I spend more time on your home page, it indicates home page contains more information, right? If I just click and go to the next page, no, it shows this page doesn't have any information, but the next page, for that reason, it is going to the next page. So topological frequency utility mining, this is one more model which has been implemented. If we observe, no, like very good survey is done. If any researchers know, you can go through this particular paper if you are willing, and which are different weighting factors and even time complexity we have included and limitations. And the next topic on this is one more paper. It is amalgamation of web usage mining and web structure mining. So log file of a server combined with structure of a website, it is being presented. And this is a very good result which is being presented here. Out of all web pages of your website, no, which pages are excellent, which pages are medium, which pages are poor. So that when you say poor pages, no, why they are poor and why it is the heavy content is not there, and why you want to keep such pages in the website, right? So this can be done. And this is how the model is represented. First log file is cleaned, it is pre-processed, and using some of the data mining approaches, we are with classification and clustering algorithms. All right. With those, I'll get the patterns and get knowledge from. See, I have huge amount of information, 500 pages of information. Get the this. I don't know how to use it. So this is how I can categorize and I can make my model very strong compared to other existing models. And
Madam,
at the end, I'll be classifying them as web pages. Yes, sir.
madam,
Over, sir.
5 minutes, madam, please, madam.
Eh, okay, sir. And this is the categorization, and even it can be applied for various e-commerce transactions also. Most of the web users, most of the customers who are prompting for some of the equipments, some of the products, right? Those can be excellent customers and medium customers. uh, Rarely visiting customers, right? This is, and there is one more thing wherein we are going for a hashing mechanism, so that it is as good as telling like whenever we go to some more or something, no? We see like most customers which are frequently purchasing some of the equipments, no, those can be kept very near to the door, very near, so that we can reduce the time of customers and even the space can be saved. And, this is one more thing which is published in InterScience. It is a coalition of big data structure and usage mining, because nowadays we are working with petabytes of information. And this is web usage mining. And, this is one of the thing what I told, web content mining. No? So document source is available. I want to have a cluster of various documents, so I can go for content mining, right? And this is internet is with a number of documents available. Query is given by the user, and information retrieval system is responding and ranking the documents and giving the response. So this is how the IR system is designed, and this is hashing. Okay, I can give a link. So if somebody purchase bread, they will be taking purchasing jam also. So I can give a link. So this is how even it can be applied for any of the social network criteria, any of the domains. And, thank you. Any queries?
Okay, any questions from audience? Okay, thank you, madam. Some others are waiting.
Yes, sir. Okay, sir. Thank you
Thank
very
you so
much.
much, madam. We got more information. Thank you, madam.
Thank you very much.
Okay, thank you.
Okay.
Sir, Binay, sir. Yes, sir. Yes, sir.
Yes, sir.
Sir, members already posted their abstract number in the chat box.